more after that to the map collections that we have already. And then within the perspectives, it's more the question of 3D, where are we going, what will be the use in future for our maps, how are they used, and what for, and why is it necessary to have them, especially digitally, and yeah, all these things. This will focus a little bit, perhaps too much from your side, but it will focus a little bit on, especially numerical groundwater modeling questions, the connection between GIS and numerical groundwater modeling. Yeah, then I think we should have a short look back, not too much. And I will give you also some announcements about short courses here in Halle. We will see how it develops, perhaps also in Berlin. But if students are interested in taking part at short courses here in Halle, there is the possibility in general. Because most of the short courses in GIS, in numerical groundwater modeling and so on, will be digitally, and therefore it's possible also to take part. They will be also in English, and therefore there is a chance to take part here. Okay, so let's start. As you see here in the chat, please, any questions, ask them. Yeah, don't hesitate to ask. Also, after this week, this strong week, I think for some of you it has been completely new world, and yeah, I hope it was then interesting. But we will start by now. Okay, so structures of map-oriented projects. Yeah, we can organize our data, or if you have a project, then of course you have on the one hand map data, but on the other hand also some spreadsheet data about, for instance, some time domain data, some time series, groundwater levels over time, or some hydrochemical measurements and so on. This will be time scale, and you have also DBMS data, data management system data. You may have also your report somewhere, and yeah, all this has to be organized, and yeah, therefore it is good to hold several data in certain folders. And one thing is, of course, the possibility to separate really the according to the formats. On the other hand, it's perhaps also helpful to separate them according to the topics. Groundwater recharge separated from numerical groundwater modeling topics, maps from somewhere else, either raster data and or vector data and so on. So please have in mind to organize this on a project level. Yeah, and perhaps in the companies where I worked so far, we organized always our data sets like this, that we have that we order them, or that we subdivide them first of all into projects, and then we have a certain structure below these projects, and this is always helpful, especially if you work together within a group, that you have a common or a general structure here of your data sets. Yeah? And this may be helpful here to organize your data. Okay, questions about this? It is very short. this part here. In general, we will not have such a long session today in the morning, and as I said, in the afternoon from 1 o'clock on here in Halle, in Germany, from 1 o'clock on we will have the exams then. But I think we will end up at around about latest 11 or something. You know. And no questions about this. Okay, you organize your data on your own. Yeah, okay. Maps and atlases, yeah, map collections perhaps better, because as you saw already, if you have hydrogeological maps, it may be the YMAP or the with the IHME it's a little bit different, but all the other hydrogeological maps, or most of them, are not one map. There are a lot of topics. There may be one sheet, but there are a lot of maps, a lot of topics that may be covered, and therefore you have also several maps. Therefore, perhaps it's a better word to say map sets. Okay, we have, for instance, the Hydrological Atlas of Germany. In German, it is called Hydrologischer Atlas Deutschland, HAD. By now, or the new one is, the new edition is 1 to 2 million, scale 1 to 2 million. We had the first edition in the 1980s, late 1970s, like beginning 1980s, somewhere there with 1 to 1 million. And and there you get really a lot of different information, not only about hydrogeology. There are about 6, 7, 8 topics in hydrogeology. So the general hydrogeological map, but then there are the regions and sub-regions. There is a map of groundwater recharge and groundwater hydrochemistry or hydrogeochemistry, yeah, in general there are really a lot of maps, yeah, therefore is very important database. On the other hand, you can get it only as a PDF, as far as I know, not in the vector data sets, and this makes it not so easy to handle. And yeah, especially with all these symbols upon the colors, this makes it difficult to reproduce, yeah, or to use also these maps in your GIS. Yeah, of course you can geoarrange everything and work with this then, but on the other hand, it would be nice if it would be in vector data, but there are too many authorities and administrations involved in this. There is the Meteorological Survey, there is the survey of the surface water, so-called BFG, Bundesanstalt für Gewässerkunde. There is the BGR, which is our geological survey, is involved. There is the University of Freiburg in southwestern Germany involved. And so a lot of interests, and they don't want to set their data free. On the other hand, this is a little bit tricky because in Germany we have a law that we should get environmental information for free or just for the price of copies. Umweltinformationsgesetz. And along this law, normally the authorities are held to give free their environmental data, as long as they are not bound to certain persons, also industries or whatever. But if they are not belonging and taking belongings of personal data, then they should be set free. And in this case, especially the Hydrological Atlas of Germany, there is nothing like this. It was on Wednesday, I think, I got a message that also our survey here, not the geological survey, but the general survey of Saxony-Anhalt, has given free the data set for height models in which resolution we wanted, and yeah, really a lot of data. And I was very glad about this because on this base we have a reliable database and we can work on good data. And this, on the other hand, the data set or the registration and recording of data is already paid because these authorities work and they have to do their work. So if they produce data, they perhaps should not give it for free, but for a low budget, just for copying and something. So this is a little bit about the discussion behind it and behind the question of setting free data or getting free data. Yeah, the Hydrogeological Map of Europe, the International Hydrogeological Map of Europe, the IHME, we mentioned already, scale 1 to 1.5 million. It has in some terms better database and gives more data, not only in other countries. It does not only extend our knowledge, but or in terms of space and spatial or aerial information, but on the other hand, it will there are also a lot of more features or a lot of features in this IHME. Yeah, for instance, the big springs and so on, or the big waterworks, they are they're available. Yeah, another big project here in Germany was the Hydrogeologische Übersichtskarte. So this is an hydrogeological overview map in scale of 1 to 200,000, as you see here. This is finished, this map, already for all over Germany. In parts you get it for free, in parts or in some federal states or for some sheets, you get it only as a printout. It's a little bit tricky, but in general, or in most cases, it will be as a map service. That means you have it in the you have it free in the you see it in the internet, but you cannot download the data. This map was very, very important for the Water Framework Directive of the European Community, and therefore there was some strong advice to finish this map as soon as possible. And yeah, it's quite a good map here. Some words about the web services, the web GIS, web maps, whatever you call it. It has the advantage here of that the authorities have only to set up one version, and you will always get the most actual and most recent version here in the internet presented. And there is no necessity, if there are users who get this map, let's say in let's say 10 years ago, who got this map 10 years ago, to update them. And so this is a big advantage for the authorities. If there is some new edition, if there are some new boreholes or some new measurements and so on. And if they want to correct their map, they have to do it only at one point and not spread it around. On the other hand, a lot of authorities, especially also Berlin, it is very, very informative. They give on question. If you ask for this, they will give you also the geometries for free. I know this from the Senate of Berlin. This is really, they do it since very long time already, since the mid-1990s already, that if you ask for the data, you say, I'm from the university, and I want to use the data sets for instance, my master thesis or my PhD thesis or whatever, you will get the data really for free, and they are very nice. There are a lot of nice guys, and they help you also with data formats and so on. Therefore, ask for data if you need them. Normally, you get it for free. If they hesitate, if the authority hesitate to give it for free, then sometimes the hint for the environmental information law, this helps also sometimes, but normally you will get it directly. So this overview map 1 to 200,000, I think over the time it will be also somehow for free for all over Germany, with a complete and quite good organized structure that is on the one hand near to the standard legend, but also to the geological maps with their lithological description and so on. There are also some hydrochemical maps in it. Then in the federal states we have also maps in different scales with different topics. Of course, if you have something like the Saarland, which is very small, they can have a map in 1 to 1 in a scale of 1 to 150,000, whereas, for instance, Bavaria, they have it in 1 to 500,000, or North Rhine-Westphalia, or something like this. In, for instance, Baden-Württemberg, in the southwest of Germany, the federal states have it in 1 to 350,000, which is quite a strange scale. But okay, this doesn't matter. They give also there in the southwest, Baden-Württemberg is also very free in geoscientific data sets. They have really a CD you can order where you get the mineral resources map, the hydrogeological map, groundwater vulnerability map, and a lot of these maps just on one DVD or CD for, I think, 10 euros or 20 euros or something. Also, the geological map of Bavaria, it is also in this range, 20 euros or something. And then vector data, not some raster data that you have to georeferentiate or something. Older maps that were produced in former times, especially in the last century, let's say like this, they are mostly analogous up to now. And you can get scans then. Sometimes you even have to do it on your own. I mentioned very often this hydrogeological map of the former GDR, and we will come to this also once again. And of course, this data set is only available as a scan. This is there is no digital data set behind it, and therefore it cannot be. It can only be served as a scan. Okay, and not only the geological surveys have maps, or the European countries have maps, but also water authorities or agencies or the administration there, they have so-called water frameworks, Wasserrahmenrichtlinien in German. And these are made normally either on the level of federal states or subdivisions of this. Let's say, for instance, I don't know it exactly. Of course, for Berlin, we have only one Wasserrahmenrichtlinie, nicht Wasserrahmenrichtlinie, Wasserrahmenplan, sorry, Wasserrahmenplan. For Berlin, we have only one Wasserrahmenplan. But for instance, Lower Saxony, there are 3 or 4 of them for different areas, for different parts of Lower Saxony. Because if you have such a big federal state, then this doesn't make sense anymore, because the topics there with the waterworks, the outline of drinking water, protection zones, and all these things, which are more near to the water authorities, not so much to the geology. Especially also technical questions, they make only sense on a small scale of let's say 1 to 50,000, 1 to 100,000, something like this. Different scales, of course, and the topics are also very different. It depends a little bit on which water authority you connect, and if you go to the water supply, you get, of course, under other topics than if you go to the authorities for the surface water, for the canals and the rivers and so on. And therefore, you first should have a look what is available, what has been published in this frame or from this authority, and what do the other authorities in other federal states do. Environmental authorities also have a lot of water-connected environmental data, but of course they will focus also on atmospheric data, meteorological data, and the hydrochemistry, the chemistry of the atmosphere, and they will also serve soil data and so on. This is not always what we want, but from time to time we have also there good information. Environmental atlases should be of Berlin. Berlin I mentioned already, and I gave you also the internet, the web address. But there is also an atlas for the surrounding of Frankfurt. I think also Munich and Hamburg, they have environmental atlases. By now, with Cologne, I'm not sure. But also some other areas, I'm not sure about Stuttgart and so on, and other cities. But some of them, there was also some nice environmental atlas of Bielefeld. So this is quite a small town, sometimes even even smaller cities have their own environmental atlases. Of course, you have to see if this city has nothing to do with water, which is quite rare. But if there is no water topic, or water is no topic, then of course you will only have 1 or 2 maps or map topics here, and but in other cities water is a big topic. For instance, in Berlin, because all the water supply of Berlin all the water demand is covered by water from Berlin itself. So they don't import their water as most of the, nearly all of the big cities in Germany do it now. Normally you have a big pipe to some far away, a nice landscape with not a lot of contaminated, with less contaminated sites and so on. Low number of, less contamination, and with sometimes even better groundwater recharge conditions. Yeah. Okay, I have given here you only two links. You see, you have the PDF available. This is on the one hand the environmental atlas here and of Berlin, and then I also gave you an example for the Höchst 200 for this overview map of Rheinland-Pfalz. Yeah. I just picked it there. You may pick also. I think for Saxony it's also available in vector data format, in shapefile format. Yeah. So maybe, I don't know where you are working in Germany. The Berlin students especially, but if you are working in another federal state than Berlin, then it's ask for it. Look in the internet, have an overview, get an overview, and try to get the data there. Okay, EC framework, Water Framework Directive was very important. Of course, the IHME was used at the first step. But on the other hand, as you know by now, the Water Framework Directive says you have to work in catchments, and it doesn't matter if half of the catchment is France and half of the catchment is Germany. You have to work together to get a complete plan for this catchment, and therefore, it's quite interesting, the results there. So the hydrogeological overview map was the result of the result of a big project there as a part of the DC Water Framework Directive. If you look for this in the internet, especially the Groundwater Daughter Directive, you will also find, for instance, a map of the monitoring wells, and this is quite interesting. If you compare this then with the nitrate monitoring in Germany, this is quite interesting that you have very, very big differences. So for the nitrate monitoring, Germany is one of the least states, one of the last states with lowest number of monitoring wells, whereas in the general monitoring we have most of them. So in Central Europe we have high density of groundwater observation wells in general, and we have organized this on several on different levels. Of course, we have the nationwide level, we have the federal state level, we have the towns and the waterworks, the water supply with monitoring wells, and we have below this even for certain contaminated sites we have monitoring strategies, and therefore we have really a lot of observation wells. In general, you can say we are by now, at least in the federal states, where we have which are spatially big, there we have a resolution, or we have one groundwater monitoring observation well for each square kilometers at least. Or in some parts, of course, you have some tens of them per square kilometer, especially in Berlin. They have on their 880 square kilometers, they have around about, what was the number, 2,500, out of which around about 1,500 are observed by the waterworks and 1,000 by the Senate. And yeah, you can calculate, of course. Okay. So small-scale hydrogeological maps, also mainly from the geological surveys or the environmental surveys. I mentioned already the medium scale hydrogeological maps. With the 1 to 50,000, it's a little bit complicated, and it goes on by now. And in former times, in the last century, just to take this again, there was here and there one map of scale 1 to 50,000 in Western Germany, of course. But it was not complete, by far not. Sometimes Bavaria and North Rhine-Westphalia, at least in the parts where not in North Rhine-Westphalia, in the eastern parts of North Rhine-Westphalia, that means on the right-hand side of the Rhine, there was a coverage of less than 50%, by far less, around about 20% or so. And but by now it is step by step completed. You will get also a lot of information in terms of geothermal questions. So especially there, the knowledge also about hydrogeology is extended very much. This is also very interesting. A lot of, or there are certain projects on a lot of topics aside from the hydrogeology that lead to not directly hydrogeological maps, but to the that will add some knowledge about hydrogeological structures and so on. For instance, if you think here in Germany, we have of course cold winters, and this means we need some heating, and this heating or can be also built by geothermal energy. Yeah, you can also use geothermal energy to heat your houses, and for this you need, of course, boreholes. And the typical depth of these boreholes is around about 100 meters. And this is very interesting for the hydrogeology. So you get from these boreholes a lot of information about the hydrogeology. This helps us as hydrogeologists very much. On the other hand, the drill rigs and the people there are drilling boreholes. They are not geologists and not hydrogeologists, and therefore it is a little bit tricky with the data sets that you get there. So if they come, if the drilling company comes somewhere from the Ukraine or from Eastern Poland or wherever, or Romania, then of course they have no idea about the geology here in Germany, and even the German drilling companies they sometimes have no good idea about the geology, because they are drilling, they are doing their technical job, and they do it very well, this is clear, but they are no geologists. And so you have to interpret this, and the geological surveys have to go to these boreholes. They don't have, on the other hand, the manpower to go go there to have a look at the cores there at the for these geothermal these borehole heat exchangers. They drill for the borehole heat exchangers. So there is the possibility that you get a lot of data from these activities, and some of them, some of this knowledge, some of this additional hydrogeological knowledge is also used for hydrogeological maps. But in most cases it is not, and this is a little bit of pity then, of course. So about the HK50 in the Eastern Federal States, I talked a lot already. Once again, there was a question: why did they do it? Why did they compile a complete map from north to south, completely covering the former GDR? The background was it was a resource. It was like a mineral resource, like gas or oil, or the lignite, or gravel. It was an important resource, the water, the groundwater. And therefore, they had a strong survey, they had a good monitoring, and they also set up a very detailed hydrogeological map here. This HK50 is also reworked by now, but on the other hand, sometimes it is very difficult because the database for this HK50 was secret, and it is not shown on the map. There is not every borehole that they used for the generation or creation of the map. Not all the boreholes are described somewhere. So this is a weak point here of this map. If we come back to the former GDR, there is additionally to the hydrogeological mapping, there was going on, or in advance, a little bit earlier, there was going on the quaternary coverage mapping for especially the northern parts of the GDR. So this is northeastern Germany, then Mecklenburg-Vorpommern, the federal state of Mecklenburg-Vorpommern, Brandenburg, parts of Saxony-Anhalt, Berlin, of course, and parts of northern Saxony, where we have this Lithophasis-Kartenberg quarter. Yesterday we talked about cross-sections and how complicated it is to read the cross-sections map in the HK50. But on the other hand, in this Lithophasis-Kartenberg quarter, you will find very, very detailed cross-sections, and they are geological cross-sections, not hydrogeological cross-sections. They are not schematized in any way, but they are real geological cross-sections. So if you need something like this, try to get these maps. They are very, very good. They are on a high scientific level here. On the other hand, this NAU Kartenwerk, Niederschlag, Abfluss, so precipitation, runoff, and difference between precipitation and runoff. This map set is not very helpful. In certain questions, for instance, for the question of groundwater recharge, this is helpful, but normally not. Yeah. Okay. Yeah, small-scale hydrogeological maps, mostly for contaminated sites and so on. So, for instance, for Bitterfeld, you get also a little bit bigger scale, larger scale, not 5,000, but perhaps 25,000 or 20,000 scale 1 to 20,000 maps. But sometimes if you have just an industrial area, then the scales are sometimes 1 to 1,000, 1 to 5,000, something like this. Yeah. Okay. So, what are they used for? Once again, it was the question at the beginning already. The question or the background is that maps can be read by a lot of people. Yeah, they can interpret this by using the legend and by using their own spatial information that they have, and this really helps a lot. It makes your work especially transparent, yeah, and therefore you should use maps as extensive as possible. Yeah, yeah, some things about this, but yeah. Transparency is a very big advantage. At least you see it also. We have in Germany by now a big discussion about Corona, the whole handling of mask, of the vaccines and so on, the vaccination process itself and so on. And also there, transparency is most important. But this is the same for all of the environmental topics. Yeah, you have to be transparent. You have to be transparent about your input data, about your modeling and processing techniques, about your field work, the results there. And therefore, maps help really a lot to make things, to make the work transparent. The results afterwards, of course, this is most important. So hydrogeological maps help really a lot. And GIS handling, especially far beyond the hydrogeology, this helps especially very much. What's that? The IT systems here are. But now it works okay. This spatial information is today, and therefore we step by step come now to the perspectives. What are they used for in future? These spatial data and the maps, also with them. They are used especially for numerical models, because numerical models have the advantage then that you can calculate for the future, that you can calculate prognostic settings. If you want to calculate, if you want to set up a new well, extraction well, if you want to change the some things at the surface waters, if you want to build a new house, whatever you want to do. In hydrogeology or hydrology, you can calculate prognostic models. And this is a very big advantage that we have. Our models are, the modeling tools are very well elaborated and on a very high level already. And therefore they are reliable. Transport models of contaminations and water level calculations under certain conditions, for instance, for the climate change and whatever. So this is reliable, the numerical part, as long as you have the data for this to feed these numerical tools. And one way, of course, to feed these numerical models with the necessary data is to set up maps and to set to work really with GIS especially, so that you have all the possibilities of, for instance, regionalization methods. As you saw, TIM, IDW, the geostatistical methods especially. So this is not possible if you do it without GIS. And therefore, a lot of these tools have already connections to GIS. And this gives a new workflow. In former times, we had to prepare tables and something for data input for numerical modeling tools. By now we have, on the one hand, the possibility to set up input data, but on the other hand also to visualize results in GIS and work with this in GIS. Also with the results, you have to compare, for instance, the water levels before some dam, before you build some dam, and afterwards, after your numerical calculation, your numerical model. You have to compare this. This you can perfectly do with the GIS. Therefore, GIS is very, very helpful at this point. Most of the modeling tools are capable of reading and working, also exporting shapefiles. But these are mostly the commercial tools. The numerical calculating kernels themselves, of course, they will, or not of course, but they will not work with GIS data. So ModFlow itself, for instance, or FEFlow itself, will not work with GIS data. But the pre- and post-processors, they will support you to import GIS data, and especially the shapefile format that we used also here in the course is in most cases supported by these pre- and post-processors. If they are called Visual ModFlow or GMS or Processing ModFlow, Model News, or whatever you take, or FEFlow or something else, they support data import via GIS. And this means that it is a good strategy to hold all your input data and to set up also all your input data in a GIS. Don't ever interpolate or regionalize, let's say, hydraulic conductivities within such a preprocessor. Don't do it with Visual ModFlow. Do it with a GIS and then import it into Visual ModFlow. This is the much better way, because in GIS you have on the one hand the means, to, for instance, regionalize data, and on the other hand to visualize this, to make everything transparent, to show, okay, we have there our wells, we did our pumping test there, we regionalized this, and we with this method, and this was the result, and so on. This is all possible within a GIS. even the methods for regionalization are very bad, for instance, in FEFLOW, yeah, but also in Visual ModFlow, in GMS, yeah. They are not made for this. They are made for import, setting up all the data structures for numerical calculation, and then after that as post-processors for the visualization, for the first visualization of the results. Yeah? And therefore, it is good to hold and to set up all the input data in a GIS. The other advantage is that you have is that you can then work and you can also switch from one numerical tool to another. Yeah? If you have all your input data in a GIS, in GIS data formats, in shapefiles, in raster data formats, then you can switch from, for instance, FEFLOW to ModFlow, or the other way around. Yeah? It is also then a little bit of work, but it is not impossible. Yeah? If you take just FEFLOW data and you want to go to ModFlow, oh, this doesn't work. Yeah, it will. You have to write a lot of interfaces to transfer data. Yeah? But if you have it in GIS, then you can say, okay, the customer there or the consultant there for this purpose wants to have it modeled completely in ModFlow because of these and these and these questions, and I did it all in Sutra. Yeah, no problem. Data set or the input data is held in a GIS database, and I can transfer it from this GIS either to Sutra or to ModFlow or to what else? Not FemWater. FemWater is out of, but yeah, there are some other. So, for instance, if you go to Saudi Arabia, there it is only allowed to model, or if you get a contract with the government there, all governmental models, hydrogeological numerical groundwater models, have to be done in ModFlow. Of course, ModFlow is not the most efficient one, calculating kernel and this and this and this. Yeah, it has these problems, but on the other hand, and therefore you may say, no, I will do it. I'm used to FEFLOW, and I will do it in FEFLOW, and then just transfer the data when I'm ready. I know about input-output data, about how distributions of dispersivities looks like, or what are the sources, and so everything. You did your modeling in FEFLOW, and then you transfer your data just for this contract to ModFlow and give it to the government then. Yeah. So this is also another question that you should have in mind. Most of the governments have to use open source tools, because in closed source tools they cannot prove the reliability. So this is a little bit a disadvantage for FEFLOW. This is helpful if you want to calculate for a project. There it's on the one hand convenient, but it is especially very efficient compared to ModFlow. But on the other hand, ModFlow is not only for free, it is open source, and this is a difference. Of course, for a government like Saudi Arabia, it's no problem to buy FEFLOW. No, this is some $10,000 it's nothing. But on the other hand, they don't get insight into the code of FEFLOW, and therefore they cannot say, okay, it is due to this mistake or to this problem there in especially this modeling tool, and we have a workaround, they don't have access to the code, and this makes it sometimes problematic for authorities to work with non-open source tools. We have the discussion also by now with starting with the operating systems already. So Windows and Microsoft software is by now, I yesterday read it once again, is very much in discussion because it is not transparent. You don't know what data are given or have to be transferred to Microsoft and to which part of Microsoft and so on. And therefore, the authorities have a lot of problems with this, and especially for the open source tools, this is not problematic. For the GIS tools, it is not the biggest thing because GIS tools normally use or are made and are used for the visualization of certain things, and this is not so problematic as, for instance, the numerical part, the numerical calculation part. Yeah, and therefore, even our BGR, if you have also our geological survey here, if they work somewhere if they have projects somewhere in the world outside of Germany, then in the support of other states, of other nations, then they will always use open source tools. So if you want to calculate saltwater intrusion, then Sutra or Satra, and if you want to calculate flow and transport, then ModFlow, and so they have different tools, but always open source. And the big advantage is when the code is not only reliable, also FeFlow is reliable, or PC Geofilm here in Leipzig, it's reliable, it is proven and everything in a lot of projects, but they have access to the code, and this is the big advantage there. Okay, so change of modeling tools is possible if you have if you have your database images in a universal data GIS data format. Yeah. So data exchange with numerical models in terms of drinking water protection zones. The maps are used on the one hand to outline drinking water protection zones, considering the groundwater protection, the groundwater vulnerability. So this is one big input for the unsaturated zone, and for the saturated zone it is most important to calculate path lines and to visualize them in the GIS also the path lines. This is also necessary by now with this big discussion about nitrate for the observation wells for nitrate, the monitoring wells, or the nitrate monitoring here in Germany. There is very often from the agriculture the question, where does the water come from? It doesn't come from our fields, it comes from the street, and it comes from the industry. It doesn't have anything to do with our fields and the agriculture. So don't blame us, and don't force us to reduce our fertilizers. We don't have to do anything with this. Or this is some waste disposal or whatever. Path line calculation is also very important, and to visualize this afterwards, especially for drinking water protection zones, for the outline there, it is very important. Also the isochrones for outline of the distinct protection zones. There it is very important to use maps, of course. Big construction areas. So, for instance, in the center of Berlin, there was this big construction area of the Potsdamer Platz. There were really a lot of buildings set up. They are near the so-called Tiergarten. This is an area, a recreation area with a lot of old trees, and these trees have a good connection to the groundwater because they are. This recreation area is in a valley, and therefore we have shallow groundwater, and the trees are used to this. If you come with a big construction area aside of this recreation area where you have a groundwater withdrawal and drawdown, then these trees will dry, and this nobody wants, of course, and therefore you have to protect this. You have to calculate numerical models, and you have to show groundwater ISO lines, and you have to look for the in the construction areas for the groundwater chemistry, because if you insert there some cement, then of course groundwater chemistry will change, and especially in this case they planned to do this without extracting so much groundwater, and this means they had to build a coverage deep in the groundwaters, in the saturated zone. They had to inject some things, some chemistry, and this was at the beginning mostly sodium aluminate and sodium silicate. And if you afterwards put then some cement in it, then the pH will completely change, and sodium aluminate and sodium silicate are solved then, perhaps, and especially aluminates are very poisoning for trees, and therefore it was quite an interesting, or it is always quite an interesting topic. The hydrochemistry, the groundwater levels, the path lines, where does the water come from, where does it go, also for construction areas. Yeah. Okay. This was a little bit about the map sets and the future use of maps, but the future development will go into 3D, of course. We are not content, it's nice to have it in 2D and to visualize, for instance, some yields and some hydrochemistry in 2D, but in 3D, of course, but the world is in 3D, not only with the houses. I'm in the 4th floor of a big building. I'm sitting here on the 4th floor of a big building, but also in the underground. And of course, there is a distribution of certain chemical parameters. Is of course 3D distribution. This is only hardly. This can only hardly be done or visualized and made transparent by maps, and therefore the future development will go into 3D. On the other hand, also the question of database. The connection to databases will be necessary because you have to calibrate models, you have to show monitoring results and so on, and all this is held in a lot of cases in database management system or in the database then. Yeah, so let's have a look at a lot of pictures by now. So, for instance, GRAS was also in former times capable of visualizing even 5D data. So, the 3 spatial dimensions, of course, this is clear, but also, on the other hand, time data and concentration data. In this case, it was 5D here. So, this is from some storm event that led to a very big flooding in Germany, in the Elbe River. There the distribution could be shown on the one hand time dependent and of course 3D in 3D. So in different levels of the atmosphere, how does it develop in the mountain areas? Where was the most rainfall falling, and all these things. This is very helpful to be able to visualize at least on this level here, yeah, and to calculate also with this. Yeah, you have seen it in GIS. There is really a lot possible already by now. This is a little bit tricky. Perhaps I can show this to you. I'm not sure. Let me have a look if this is possible to show it to you here on my screen, because this is an animation. Yeah, it works. So I can show it to you. One moment, I have to set up my screen. Okay, no, this is wrong. This one. So, okay. So here you see in the Bitterfeld area, which is a highly contaminated area, there we did in our working group the geological modeling, which led also to a lot of, or which answered a lot of questions considering contaminant distribution and the question of remediation possibilities and so on. We will have a lot of these of slides here in the next slide, or a lot of pictures and graphs in the next slides about this area. Yeah. This is a little bit around about 20-30 kilometers to the northeast of Halle. Somewhere, yeah, it's not between Halle and Berlin. Yeah, a little bit also. But yeah, it's quite near to Halle. Yeah. Setting up geological models is quite difficult. I mentioned this already. We have highly specialized tools for this. I mentioned a few of them, but yeah, it is done on a constructive way from our working group. This geostatistical way has proven not to be helpful over the time, and by now the tools don't use so much the geostatistical way, just taking some boreholes and the boreholes recording there, and then connecting this automatically with geostatistics. This doesn't help. You have to construct really, especially in areas where you have technical inputs, as here, for instance, the lignite mining areas. You have to really construct everything, and then, of course, use geostatistics. This is no question, but not using just the boreholes and then doing some geostatistics. This is not what we do here, and what has shown to be a good idea. Okay, let's continue here with our slides, because this is more transparent. Okay, So we start normally with cross-sections, in this case geological cross-sections, and we connect these cross-sections then or we create, as we did yesterday. We first of all outline the lines along the cross-sections that separate certain layers, hydrogeological units or geological units. This doesn't matter here too much. And then we, this should be on one of the next slides. And then we get surfaces or bottom faces. Of course, this can be automatically be connected. But this seems to be 3D. It is not. This is only a connection. We only have the surfaces of each of these geological layers or hydrogeological layers, and we connect them mathematically, but we don't set up a topology, and we don't fill the space in between. So we have within this volume here, we have no distribution of, for instance, hydraulic conductivities or whatever. You can create, of course, the distribution in 2D on these surfaces. This is no problem. But the problem is, or this is just an additional attribute. But the problem is, if you want to distinguish some hydraulic conductivity or some hydrochemical parameter from here and here, if you want to get a distribution really in 3D, this is not possible with these tools. None of them. And this is a problem, especially if you want to calculate numerical models, or if you want to set up numerical models based on this. Here in our circumstances with these very thin or quite thin layers from the Quaternary, this is normally not a big deal to work with 2D data. But on the other, if you come to more voluminous more to volumes, then it will be a little bit of a problem. We run into problems then. Here you see 4D, in this case only 3 pictures from different time steps, and you see how, for instance, this contamination plume develops over time. This is quite helpful to see, okay, during this time I cannot measure any contamination here at this point, but after this time I will measure the first contaminants, and here I measure very high concentrations or whatever. So this is very, very helpful. In this Bitterfeld area, it's especially important for the beavers, but because by now they get dioxin and they get poisons, and this is not the best idea for nature reserves. That the animals get poisoned there, poisoned groundwater. Okay, input data, or we have sometimes used here, especially from the Eschwege area, the interpolated ground surface, but you will get much better data via LIDAR, via laser scan. And this is these are the methods we use today. I don't know if by now already all over Germany we have laser scans, but especially for the towns and some environmentally interesting areas, we have these laser scan data. And this is resolution 1 by 1 meter and exactly on let's say 10 centimeters, exactly the height. And it is not the height of some GPS or whatever, but it is the height of the survey. Yeah, and therefore this data set or such a data set helps really a lot. Yeah. This helps really a lot. Yeah, so we start always with these 2D cross-sections and of course the geological map. This helps us to set up these cross-sections, and then we do a lot of these cross-sections. Yeah, in this case 28 here for these 4 by 4 kilometers or 4.5 by 4.5, something like this, kilometers. This means we have a high density of information, not only boreholes themselves, but also additionally along these cross sections we have information. Yeah, and this is not just connecting from there to there, but there is some knowledge input. If we go back to the cross section here, this knowledge about this this channel here, this glacial channel, this is only available because we know, okay, 1 kilometer far to the north, for instance, we have one well which shows also this channel, but we know the channels are flowing from north to south, so in the north it should be with a higher bottom, and in the south we know it should be on a lower bottom. Yeah, otherwise it doesn't make sense. That water always flows down. And from this additional knowledge, from this expert knowledge of the geologists, we can create and generate much more detailed models than just by connecting, for instance, this stratigraphical unit with this stratigraphical unit. Yeah, this doesn't make sense, or only makes sense sometimes. Yeah, if you have marine settings with big big coastal areas and sand at these coastal areas, something like this, this is no problem. But especially in the glacial settings, we have very high heterogeneity. We have tilts and we have sands and we have especially also these glacial channels and gullies that will lead to a very high heterogeneity here. And if we can use all this knowledge of from the geology, then we will get to a completely different numerical model than just by interpolating a dummy bottom or dummy surface. Okay, so a lot of these cross sections, and this will then lead to such nice pictures here. Here you see in red the connections between the hydraulic connections between different aquifers. Here between the quaternary, this above this red area, and the tertiary below this red area. Yeah. So here we have no aquifuge in between. Yeah, in this red area. All around here we have it, and the same between two quaternary aquifers and so on. Yeah, you can, if you have a complete geological model, then of course you can derive at least a few hydrogeological structures. Of course, a geological model is not a hydrogeological model. This is clear, or hydrogeological structural model. Because within one stratigraphy, you may have completely different lithology, and hydrogeology is mainly or is focusing more on the lithology than on the stratigraphy. Yeah. So here, this is also a nice picture of this channel. You can cut from the prepared 3D model, the finished 3D model, you can cut out certain slices, vertically as well as horizontally. Vertically we will see also afterwards, but here horizontal slices. And you see, for instance, this channel, how it encaves into the underground, how it goes down, and how in the underground, the contaminants will flow along this channel that is filled with gravel, along this channel, then to a certain other site. You know, in this case, it's also a lignite mining area, and to hold it dry, we have a lot of pumps here, and therefore all the water will be dragged through this channel, and all the contamination also will be dragged through this channel to this mining area. And so it is quite reasonable that at this point here we have the highest contamination, and yeah, there it is quite suitable to set up a remediation plant. Yeah, but as soon as the pumping here in this area stops, and as soon as the water levels are going up, and perhaps leading to completely different path line directions, then you perhaps get clean water, and this channel here is only very small, so there is only short time where you get, after stopping the pumps here and after completely changing perhaps also the flow directions, there will be only a short time where you get, after stopping this, the high contamination anymore. And your remediation plant is then at completely the wrong site then, and you have the completely wrong method to remediate then your sites, your contamination. Yeah, and so this was also the case here. They stopped the pumps here, and then 2 years later they got clean water after having the highest contamination before. So it's a little bit tricky, and yeah, this we finished our geological model just when they wanted to stop the pumps, when they have decided to stop the pumps. So the one decision was made, and in parallel our model was constructed, and then after stopping the pumps, we said, yeah, okay, we know in 2 years you will get clean water, but the decision was done to stop the pumps. Okay, some more cross sections in this case, of course, from the finished model, not from the not to set up the model, not these 28 cross sections that we did from the boreholes. Yeah, this is just from the finished model. You can cut out a lot of things. Yeah, also very interesting in this area, due to stopping the pumps and due to some flooding event in 2002, groundwater levels in this mining area has risen for about 9 meters. 9 meters. And then, of course, the question is, how much water does this mean? How much water is flowing from this flood into the groundwater, into the aquifer, and how much water is only piled up in the aquifer just by having pressure against it is flowing, but there is no, perhaps no surface water flowing into the groundwater, into the aquifer. So in this case, this was the case. So the amount of water, so on the one hand, we had, of course, a big volume that has been filled by this rising groundwater level, but on the other hand, the surface water intrusion was only a few thousand cubic meters. This was really not a lot, but due to the pressure, due to the high pressure in the filled former lignite mining area, the groundwater didn't flow anymore and could not flow into this mining area, especially, and therefore, if you have a pressure here, then of course your groundwater level will also rise and not only flow the surface water into the groundwater, or not so much in this case. So it was quite interesting to model this, to calculate this, and to see that the results are correct. This is the most interesting thing. You see, okay, your modeling tool, it calculates something like this. Yeah, you can also kill a coconut. You can also do something else and read from some coffee. But it is correct. It could be shown that this was correct then. Or we found out after this flooding in 2002, we found out this was correct. The calculation was correct. And this is also one thing I must say is very important was very important for me. I did a lot of these regional models around 10, 15, 20 during my time, not only in the university, but also working in a consultant and in the BGR before. These models, they are in a certain range, of course, they are correct. You cannot rely on milligrams per liter or something, this is clear. But the general outline is correct. And this helps really for future, if you look at climate change models and so on. Also there, even the models from the 1970s, they are in a certain extent correct. You can say, yeah, it works like this. Yeah, not in detail, of course. You cannot derive from these models from the 1970s a storm event here for several square kilometers. This is quite clear. This is not possible. But the general direction. Yeah, we can do a lot, and this is nice to see. Okay, also some contaminant plumes can be calculated here with these models and shown in the maps in 3D and especially 3D and in 4D, especially here for the path lines. It was very interesting. So complete change of path lines due to the flooding event and so on. So I don't know if I have this here, if this runs also on my, let me have a look, if this animation runs also on my presentation here. I don't know. No, this doesn't work. Okay, I have to rework this sometime. Okay, so this plume is extending here in 3D, of course. So I'm sorry that I cannot show this to you by now. The animation only here with the second image from this. Okay. So what do the federal states do? What do our authorities do, and what do universities do, and how is the research going on? And here you see the federal state of Saxony, and they set up systematically, and they collect systematically data from consultants who get money for setting up hydrogeological numerical models. And so they can cover with regional models. You see, these are now local models here, or these you don't see it, but you can imagine these are now local models. These are more or less regional models. They set up and collect data and work with the data to get a real 3D model, hydrogeological model of the federal states, not for the whole federal state in general, but for certain projects, for certain topics. They get the data, they collect the data, and they also use the finished models, the proven models, after that to cover their whole area. And these hydrogeological models then, and also the hydrogeological maps can be used for other purposes. So they were set up, of course, here in Saxony, especially in the north, for the lignite mining. But of course, lignite mining means also there is some industry, and this industry also contaminates the underground. And then they can use these models also for the calculation of contaminant plumes and so on. Of course, always to a certain extent, and always they have to add new information or additional information, just new parameters and so on, to come from just a flow model to a transport model. Of course, you need sorption parameters, you need you need new sources of contamination and so on. But these models tend to be used in a more general way than they first were intended for, and they first were set up for. So this is the way it goes here in Germany, step by step. Also Saxony-Anhalt wants to do this, and Lower Saxony did it already since long time. So this is one of the results here, 3D modeling, in this case geological modeling of a certain area, and connecting this model, in this case here in this project, it is not for hydrogeology at all. It is for a railway, for a fast railway track, and they needed this model to set up tunnels and bridges and so on, and or to build this in the underground or on the underground, and but this knowledge that you got by drilling, by looking for the underground, into the underground with geophysics and whatever, they get more knowledge and they connect the knowledge. Yeah, and this is most important, so that the 3D information grows over time and develops step by step. Okay. Any questions about this? This was a little bit the perspectives. These were the perspectives. A little bit also with the atlases. Look back already with the map sets. A little bit a look back, and by now the perspectives forward. Okay, then I hope that you enjoyed the course. For me, it was quite a new thing. Of course, I had a lot of courses also in English up to now. I held a lot, and I hold also in the near future a lot of courses in English. GIS courses as well as numerical groundwater modeling courses, and some even going into the questions of geological modeling, of mineral sources modeling, and in terms of modeling also, especially hydrochemical modeling and engineering, geology modeling, and all these things. So I had a lot of courses, but it was new for me on the one hand, this course. In the former years, it was always in German, of course, and in presence in the university in Berlin, in the PC lab there. So it was new to me to do it digitally here, and additionally in English. So it was quite a good experience for me, and hope you enjoyed this course too, that it was helpful for you on the one hand for your actual scientific work, but that you make the best of it also in future work. You see here, standing alone, these any questions? If you have any questions in the future, please don't hesitate to ask me via email. On the other hand, we have also some courses that I can announce here also. I don't know how we can organize that you will get it, at least in Free University of Berlin, that you can get credits for this, and that's perhaps also grades for this. But if you want to take part, just want to take part, every year around about 5 to maximum 10 with digital working, maybe also 10 students I can take with me in these courses, because these courses are mainly for our students, of course. And we have, for instance, numerical groundwater flow and transport modeling courses in September, as you see here. So if you want to take part, write me an email, and you get, just as now, get the link to the, you are invited to take part here digitally, and perhaps this is a good idea. The other thing is we have also here in our university an open source GIS course, not so much focusing on maps, but focusing on geostatistics. It's not so long as this, it's also 8 days. But more on programming. Also in the numerical groundwater flow modeling course and transport modeling course, we will have some programming, mainly in Python. But if you are used to programming in, for instance, C++, it's also very helpful. Fortran I know also a little bit, but then it ends a little bit with the programming languages. VBA is also quite interesting, and I did it also for a long time. But it will focus mainly on Python programming, this open source GIS course. So the November sessions will be only for Python programming in GIS, of course, not for Python, some Python programming. So they are courses for the whole day, and without fees, at least for students. For consultants, if you are leaving the university and going to consultants, then we should get also some money from that you get from the projects. But the fees are normally not so expensive. This is the outline of our courses here. If you want to take part, write an email. And with this, I want to close the course here a little bit. We got it even before 11 o'clock, at least if you don't have any big questions that we have to discuss about. But perhaps there are these questions, and I would be glad to hear these questions and to see.
I think most are rather anxious for the exam right now. So.
Okay.
I will ask some questions per email in the next days.
Okay. So emails was the point of my last slide here, and here is my email address. You can reach me there and ask if you have smaller problems that you have where you need some help on, or some distinct problems that can be where we can focus on certain parts of the problem very high, and so that it will be. Of course, I will not carry out perhaps you can also carry out projects together, but this will be on another level than just writing an email, of course. Okay. So, especially to those in India who will not take part at the exams, which will be, of course, most of you in India, I wish you good, by now it's afternoon. It's not evening, I think. I wish you a good afternoon. I hope that you have enjoyed the course, and I hope that you will work with the tools that you have seen so far, and that you will take the most advantage of it. Okay. Bye-bye, and see you sometime. Perhaps in Tirupati or somewhere else. Okay, for those from Berlin who take mainly part at the exams, okay, if it was interesting, this helps, and this is good to see. Okay. For the exams, as I said, at 1 o'clock, and as I said, you can use everything you want, even your grandma. You can ask your grandma if she knows about hydrogeological maps, and you can work together. The exams will be in English and in German, so the questions will also be in German as well as in English, and also
could we maybe ask about the timing, because we thought the lecture would take longer today. I'm not sure, could we maybe move it to 12? I'm not sure how everyone else is feeling about this.
Oh, I think we should have it at 1 o'clock by now, and perhaps you don't need so much time. You don't need, I think you don't need 2 hours. But if you need 2 hours, it's okay, so that it's ending up at 3 o'clock here in Germany. Yeah. Fine. So organize yourself in groups. Yeah. I would strongly recommend this because this is more effective, not only from the question of getting good grades. I will come back at 1 o'clock or a little bit before here on this canal. Yeah, this we should talk about. I will come back to this video conference at let's say 5 minutes before the exams, and you will get a zip file. Yeah, on the one hand with the questions, with the questionnaire, and on the other hand with some GIS data. Yeah, and you work only digitally, of course together, and of course with all the slides you have and so on, and you fill this exam then, and you will send me back hopefully one zip file for each person. With your name. So everybody has to send back a zip file, otherwise he and she will not get grades. Yeah? But if it is the same zip file as someone else, I cannot prove it, and you will get then the same grades, of course. This is, you may say, organize yourself also in a way that you say, okay, you will do this, you are the expert in maps, you will do this for all of us, and we just copy and paste it to Gossel then. Yeah? If you want to do it like this, do it. Yeah? But I warn you, in 2 terms, this course is not meant for getting grades. This course is made so that you know how to handle GIS. And these exams, I think you will all get the best grades. This should be. Otherwise, I would be very astonished. But most important is that you look for, yeah, we did this, and we did it in this way, and there are these and these possibilities to solve this question, to solve this problem, and so on. Yeah, this is most important in the course as well as here in the exams. Yeah. So I will just, as before, set it up in the cloud and give you the link to this zip file with the questionnaire and with the data set you work on, and after 2 hours I hopefully get back all the results. Quite easy. Any more questions? Okay, if you have any more questions, then as I said, I will be here 10 minutes to 1, and please collect the questions, and then we will solve this. Yeah. As I said, it will not be collected exactly at 3 o'clock. Yeah. If I receive the email with the zip file 5 minutes later or 5 minutes before, it doesn't matter. Okay. See you then. Have a good time, and hope to meet you sometime after Corona, of course. So the time dimension will be in future, before Corona and after Corona. Bye-bye.
Bye-bye.